DefCon convention. This meeting was held in exciting Las Vegas, Nevada from July 9th through the 11th, 1999. This is videotape number 6, Firewall Appliance, Friend or Foe.
I'm Daremoe. I'm from Columbus, Ohio, 614, and I'm the alpha dog of the wolf pack up there. We just completed a comprehensive review, took about 6.5 months, of some 23 appliance firewalls. And we're going to talk about that today, some of the things that we found. If you were at Black Hat, we covered what we found there as successes and failures. Today we're going to talk about a little bit more about the failures and some of the things that we found kind of hard to believe. So go ahead, next slide. I guess right off the bat we should talk about what is an appliance firewall. When we started this whole process, we went out to the web and just did a search on the keywords appliance and firewall. We came up with several hundred products, and what we immediately determined was that our definition of an appliance firewall and vendors' definitions of appliance firewalls vary greatly. So we're going to talk a little bit about what we kind of thought about an appliance firewall. We'll talk about some of the technologies that these products used, and we'll talk about how you in the field can know these devices when you see them and why that's advantageous to you. And theoretically, we'll talk about what weaknesses they possibly might have. And yeah, the lights would be good. You can, yeah, that's great. That's even better. Let there be light. Fantastic. Ambiance. And following the weaknesses part, we'll talk about how you can test yours or others' firewalls, and where you can find out more about these types of appliances. Next slide. First of all, we talked about what appliance firewalls are, and we were looking for devices that were integrated hardware solutions. We wanted all the software, including the OS, to be preloaded on the platform. Early in this process, we came up with a term that we borrowed from the MS folks again. We kind of took on the plug-and-pray attitude with these firewalls. We were looking for something that was easily deployable. We didn't want to have to hold hands to a bunch of folks who weren't skilled administrators in the field once these were deployed. And we were looking for something that could provide dual home network access. That's pretty much where we started with this whole process. We weren't really looking for something to firewall off a modem connection or something like that. We were looking for something with dedicated network access. And immediately what we discovered was most of these, the majority of these products, the 23 that we actually reviewed, and there were about 34 to 37 that we tried to review. Quite frankly, when we told some of the vendors that we were doing the review for DefCon, they just kind of laughed and didn't want to give us any products to review. So you guys might kind of carry that around with you. Maybe they're a little afraid of you. You can drop that in some interviews and stuff. There won't be any names, unfortunately. Attorneys have been already knocking. So, yes, there will be a white paper available, and I'll talk more about that at the end. Okay, the very first thing we discovered is the majority of these little devices are based upon packet filtering technologies, and they were very simple access control list based. They simply compared the source and destination IP address as well as what protocol you were speaking, and then decided whether or not to let it pass through the firewall and into the network. Some of them were active state, or I guess they called it active content types of devices, and so we looked at some of those, and what that did is it built a state table in memory, and it said, okay, I shouldn't be getting a SYN or an ACK from this area or this IP address speaking this protocol because I haven't initiated a session. I don't know how much that bought you, but it was a little bit better, I guess. There were a couple of them that did application proxies. Most of them were basic services only, your basic web, FTP, and those kind of fell apart as soon as we started talking about real audio, real video, or anything else that a real company might be using. And a couple of them allowed you to create custom proxies on the fly. You could do your own proxy from this address to this address, speaking only this protocol. There were a couple that were combination, and the last thing all of these devices do is network address translation. In fact, in some of them, it wasn't even an option to allow or disallow network address translation. You simply were natting, whether you liked it or not. Next slide. Some of the things we discovered is that we looked at these for some cable modem type devices, and some did support DHCP on the external interfaces. Also, you might want to notice that DHCP on the external interfaces makes for some interesting types of spoofing attacks, and the ability to possibly convince the firewall to release its IP address midstream. We kind of played with that stuff. All of them did port and address redirection, and there were 2 or 3 of them that had a possible DMZ deployment with a third network interface on the device. Many of them offered offloading of the logging, and that was a good feature. It let you move all of the log files to some other device. Of those that we tested, the majority of that information was passed in the clear between the firewall and the logging device. The interesting thing is the ones that didn't give the offloading of the device, because these are solid-state machines, they only had a limited amount of memory to store those logs in. So port flooding this thing would cause it to run right through the log files and hide all your earlier attacks on many of them. Also interesting to notice. A lot of them did alerting via email, paging, SNMP, and just basic protections against spoofing. Basically, it wouldn't allow you to, many of them wouldn't allow you to have internal IP addresses on the external interface because of the NAT. Now comes the good stuff, now that everybody knows what an appliance is, and I can stop being product boy. This is how you recognize them in the field. Right off the bat, because of the nature of the way these folks deployed packet filtering, you will find many open high ports above 1024. And these are not usually prevalent or existent in proxy-based firewalls. So if you find those above 1024s open or filtered via an Nmap scan, you'll know, for example, that this is probably a packet filter. You can also, many of these systems identified themselves via the web browser. Simply connecting to port 80 or port 8080 on the devices would pop up this great little banner telling you how to buy the product. Fantastic. By the way, if you're in marketing and you think that this is a great way to market a product, stand up because we all love you. Okay? Telnet and SSH were also in use in these devices, and amazingly, once again, marketing. Telnet in, and it tells you what kind of device it is. Many of these were solid state, as I mentioned, so you couldn't even change or disallow those banners. You gotta love that. The basic services may identify the types of devices. In this case, we were able to actually guess which which filters were in place, and we would use that to identify the devices that were being punched through to the backside of the firewall. And we'll talk a little bit more about that in a minute. Also, Nmap and Queso, we used those quite extensively in the testing process, and on many of them we were actually able to identify the underlying operating system that was laying under the application. Amazingly, most of these are based on this thing called Red Hat Linux. You might have heard of it. Next slide. The real weaknesses that we're going to talk about today. First of all, the general lack of logging. Firewalls, in general, most platforms do quite a bit of logging. So we were kind of amazed at the general lack of logging that was taking place in these little devices. Possible holes in the filtering rules, we'll talk about those and how to figure those out. DNS problems, address spoofing, some session hijacking. By the way, this is a great form of attack. This is fantastic in this case. Possible exposure of internal systems and denial of service. Go ahead. Right off the bat, almost all of these firewalls all they did was logged some type of connectivity. In many cases, they didn't even log dropped packets, only successful connections in and out of the firewall. Well, this is fantastic. We can port scan these devices all day. They won't notice. The admins never know. We can all kinds of play with some of these. The problem was a couple of them did. They did record port scans, but when you looked at the dropped packet logs, unless you were a skilled administrator and saw that there was a series of packets from this port to this port and over a period of time, you wouldn't realize that it was a port scan. None of these devices just came out and said, okay, a port scan just happened. So we kind of like that feature. You might want to know if you are going to play with one of these devices and you don't want your co-administrator to know that you've been doing that, you might want to use some type of stealth attack or stealth port scan, like an Nmap thin scan or something like that. Be careful out there. Few logged repeated connection attempts. In fact, we couldn't find any of these devices who would log the repeated connection attempts, such as in a brute force against a telnet prompt from a system that was exposed to the outside world. It just seemed to ignore it, that traffic was going there, so it must have been okay. So that's pretty useful. Brute forcing is kind of lame, but at the same time, it is kind of nice to know that you can go ahead and play those games. None alerted against attempts to overflow exposed processes. And the big thing here that we discovered is these are like half firewalls, and they aren't really intrusion detection devices. Again, part of this reporting process is that there was no clear way to identify what attacks had occurred, and we kind of like that. That was pretty fun. Almost none of them, maybe with the exception of 2 out of the 23, made any log at all of our attempts to denial of service the box. And we hit these things pretty hard. And of the 2 that did, many of them only just dumped basic Linux log files, which you would have to go through and grep to pick out. Now, how do we take advantage of some of this stuff? Well, the first thing right off the bat are these filtering holes. If you were at Black Hat and caught the extreme hacking from E&Y guys, you learned a lot about how this packet filtering stuff can help and hinder you. And I've got just some words for you there. Netcat is your friend. Get to know Netcat. Firewall is a great tool as well, and it can be used to help determine what filtering is in place, as well as locate possible holes in the filtering rules that allow you to map devices on the inside of the firewall. And that's very useful. Nmap will display the ports open by status as far as are they open, are they filtered, or are they firewalled. Get to know Nmap as well. It is a great tool. Most of these devices, as I said, allowed some fin scanning of the internal network. And a couple of them, we also noticed some things like ARP leakage, where the device would, for some apparent reason, start to ARP addresses on the external interface that belonged to devices on the internal interface. Also could be useful. Once holes are discovered and you've found ways to touch those internal systems, just exploit them using normal packets with forged source ports to reach the internal apps. And you won't even have to do that for some of them. Some of them, like I said, expose systems to the outside. The next real fun one for discovery were DNS problems. And because of the state of these devices and the way that they are created, they try to get these to market as a pretty cheap price. And I'll answer that question right off the bat. They ranged in value anywhere from $600 to $20,000. And it seemed to be that the cooler the case was on the outside, the more expensive it was. So your mileage may vary. But misconfiguration of these solid-state DNS servers was very common, and here we showed a kind of a little example of using NSLookup, where you set type to authoritative, set the device as your DNS server, and then just simply do an ls-d with the domain name, and voila, usually it would dump out all of the internal IP addresses. Thank you. That's always fun to play with. Address spoofing. Spoofing the source address may allow you to pass through the specific packet filtering rules. And spoofing addresses on the internal interface may allow you to access to internal hosts. Now, what you have to be careful of here is that the folks on the inside are not using non-routable IPs. If they are, obviously you're not going to be able to spoof those internal addresses unless you're on a local segment. So keep that in mind. Spoofing the addresses of other perimeter systems may allow you to access host applications. We found in some cases that as long as you were in the same class C as what the external interface of the firewall was, there were some inherent rules that weren't defined in the ACLs that applied to you, and you might want to be able to play with some of that stuff. My personal favorite here, session hijacking. This worked really well against these appliance devices. And all we did was we gathered connected users, in many cases, simply by fingering the device, just at the IP address, and it would tell us many times how many or what users were logged in. So we would wait until we saw somebody connected to the firewall, and we would use a tool like Hunt to grab their session, and voila, we've already authenticated, we're through, and we don't have to hack anything else. We've already taken control of sessions. This is probably the big one here. Those that didn't deploy proxy-based traversal of the firewall just simply said, any connections on this port, such as port 80, route to this internal device. And what that did was it allowed us to carefully probe and examine those systems that were exposed. For example, we could look at banners of the systems, and oftentimes we could query them, such as SendMail or other types of systems, to find out exactly what those operating systems were on the inside. Obviously, if you scan the firewall and it comes back and that determines it as a Linux box or a Linux-based OS, and you see this fantastic email system called Exchange, well, you know what's going on there. You know it doesn't run on the same platform. So query those applications for system and version information, and you'll be able to figure out exactly how to exploit those devices while passing through the filter. Next was denial of service, or DOS attacks. And right off the bat, I want to tell you, these are pretty lame unless you have something to gain. And so all of you folks who are DOSing all these servers around the country, I say thank you, because I get to travel and see the world, and they write checks, and that's very cool. We did run into a few things here. Obviously, historically, there's been this problem where if you could DOS a firewall, and sometimes, in some rare occasions, those older firewalls, and some newer ones, would fail in a completely open state. And the application would simply crash, and it would start to route traffic between the interfaces. We couldn't get that to occur in any of these devices that we tested. However, just be aware that that sometimes does exist. Also, we talked about, and we weren't able to exploit, but we really think that this is the case in some of these devices, as well as other firewalls on the market, where you could DOS the box and wait for it to reboot. And as it started to reboot, it would load routing before it would load the ACLs. So there was a period of time there where you could route traffic across the device without passing through the access control lists. And that could be very fun to play with at some point. Again, we couldn't find any time frames in those devices that we tested, but we have heard that they are out there. And so you might play with those. Typical denial of rules, denial of service rules apply. Malformed packet attacks. We were able to DOS a couple of the firewalls that way, just simply crash the stack. Normally what would happen, the firewalls wouldn't reboot. Simply the external interface would just stop functioning and stop responding. Bandwidth socket attacks. Obviously, if you have more bandwidth than your target, you can suck up all the sockets. Nobody else gets connection. Very lame, but I guess it might buy you something if you're really pissed. Floods and smurfs. That just general kind of stuff. Go ahead. Some of the other issues that we kind of discovered in this whole process was that some of the appliances pass management information in the clear. And we discovered in some cases that you could actually remotely manage the firewall once you caught those sessions and intercepted passwords. that's very, very useful. And some of these packages came with browsers or custom applications that you would load on your system, and it might be possible to spoof management information, whereas you might be able to change the ACL remotely.
What percentage of those devices allow you to have management controls on the external interface? I know some which you can't configure the external interface management.
I'd say about half, about 50% of them allowed remote management from the external interface.
How many of them that on by default?
On by default, off the top of my head, I'm guessing maybe another half of that, so maybe a quarter of the total deployment.
Could you repeat the question?
Yeah, I'm sorry. The question was how many of those devices allowed management from the external interface, and then how many of them allowed that on by default. And about 12 of them out of the 23 allowed you to manage the firewall from the external interface or remote device. And of that, about 6 of them had that on by default. In fact, there were 2 or 3 of them that you had to manage from the external interface when you first plugged the device in. You couldn't manage it from the internal interface of the firewall. The other question, the other issue that we ran into is the same as in any other firewall. If you're a firewall administrator, I pity you, because misconfiguration of these devices as well as others is incredibly simple to do. The ACL rules are oftentimes pretty difficult to understand and even harder to figure out how to deploy in the order of significance. We ran into some that read bottom to top, top to bottom. It wasn't documented anywhere, and half the time we'd call support and they wouldn't even know. So if you're dealing with software vendors too, the one thing I have learned through this process, as I explained at Black Hat, is I really pity you guys. The vendors and support people were incredibly unresponsive, and it's just, I couldn't believe it. I'll get off my soapbox now. The misconfiguration issue, we found out that some of them allowed all the interfaces to be set to the same devices, the same IP address. Think about no sanity check, here it is. These things would become bridges and route traffic everywhere, all 3 interfaces. So we kind of like that too. Now, if you own your own appliance and you want to test it, here's how to do it. First of all, take a sanity check on your access rules. Take a look at what you're doing. Figure out if you're going to pump data from the external interface to the internal interface. Where is it going? What's it doing? That's right off the bat. Use some of the mentioned tools that we talked about to test your own firewall. If you have this appliance firewall, and those of you who are security consultants or working in the field, you deploy these without testing them yourself, hey, all we can say is come to DefCon again next year and we'll give you a beer or something. We thank you. Use an automated scanning tool if you can find those out on the net. There are some commercial products if you have a budget. And lastly, I had to mention this one just for all my friends who are doing this. Hire a security professional to audit the firewall for you. We'll be happy to do that. And next slide. If you want to find out more about these, there's going to be a white paper that we will put out. It will be on www.microsolved, that's solved.com. We're hoping to have that up by the end of the month. We had meant to release that here, but we've been having some problems with attorneys and getting people to sign off on some of the NDAs. Search.
Can you repeat the domain?
Yeah, www.microsolved, that's solved.com. Yes, and here's how. The question is, if support can't help you on that, on the question of importance of the ACL order, how can you do that yourself? The first one is don't reinvent the wheel. Check with the Firewall Wizards mailing list. Some of those folks out there have used these devices. If you want to test it yourself, though, set up a couple of rules, such as the first rule in the set, allow access to port 80 on this device. The second rule would be deny access to port 80 to this device, and then see if you can access it. Try switching them around, and you'll figure out which one is in order of importance. So do that in your testing phase. Did that answer your question? Yes? Yes, okay.
say the white paper's going to be published?
Hopefully by the end of this month if the attorneys get everything done. www.greatcircle.com will have a lot of the information about the firewalls, the appliance firewalls. There's some folks out there that are working on that stuff. And there were several security and networking magazines that have done a couple of reviews on these, so check those out. And lastly, if you have other questions, feel free to ask me. And I want to thank you guys for coming. I'll answer any questions that you guys have.
You classify the Nokia device as a firewall appliance?
Yes, we do. And we did look at that device, and there will be information about it in the white paper. Yes, sir.
Looking at the higher end stuff like, say, fix and the Firewall, fixes like one risk below and stuff like that.
We did everything from just pick two firewalls, from Sonic Wall. The question was what firewalls were included, and I'm not going to go into a specific list, but we went everything from Sonic Wall all the way up to $25,000 appliance firewalls, such as the PICs and things like that.
And what was your impression as far as did price correlate anything?
The only thing that we could figure out price correlated to was how cool the case was. I mean, literally, some of these devices that we looked at were $600, and they did a much better job than some of the devices that were $15,000. So, yeah, and I want to answer another question that came up at Black Hat right off the bat before I take another. Some other folks have asked me what if there will be a current, another review or an addended review to this, and if we will continue this process. And the answer to that is probably not. And what we want to do is turn this over to the community, and we want to hear from folks who are testing these firewall devices. And if you want to add stuff in, we'd like to create a living document to let you do that. So that'll be coming up as well.
How many devices in total are tested and how long will it take?
It took us about 6 months to test all the firewalls. The question is how long and how many. It took about 6 months to do that. We tested 23. We started with a field of 34. Some vendors were non-cooperative. We did, we only included in the white paper whether or not they included VPN technology. The question was, what did we do about the VPN technology? Did we test that? We did not do any crypto analysis or any type of other application analysis of the VPN stuff.
Do you see a reason why this couldn't be done, quote, right, and do you think somebody will?
Good question. Well, the question is, do I think someone else could do this right, and do I think someone else will? I think that there are folks out there who are testing these firewalls. I think we needed to do it in a manner that these folks can understand and that suited our needs. So as far as that is, I think we did it right. But beyond that, if you guys want to do it, go out and test some firewalls.
No, I mean, do the firewall right.
Do the appliance firewall right. Yes. I think after looking at these 23 firewalls, I think what we did find was that there is a future here. These plug-and-play devices are incredibly robust for what we were expecting, and I think in the future you will see that. I'd say within the next year to 2 years, you'll see a very robust application proxy-based appliance that is affordable for folks that are using small and home offices and cable modems. So, yeah.
Did you notice any difference in the packet inspection techniques in terms of performance or quality?
Did we know? I'm sorry. One more time.
Did you notice any difference in the in the packet inspection technique, whether it's scan sheet or
The question is, did we notice any difference in the packet inspection technologies, whether it was stateful or not? Stateful inspection did help a little bit. We weren't able to do some of the less ankle biter attacks against them, but otherwise, we really didn't see too much benefit from it. And obviously, there are some cases out there where it will help some attacks and it will halt some attacks. So as far as performance went, we didn't see any implication of any problems either from that.
As you know, a lot of specific firewalls cause a lot of problems. At TCP accesses, how many of them actually have like an implicit denial that is automatically added?
The question is, misconfiguration is the greatest problem encountered by firewalls and firewall administrators. So how many of these came with an initial deny all state that was at the end of the rule set? The answer was less than half. Yeah.
Wondering, do any of these firewalls have like a certification from ICSA, IAPRI? And if they did it correlate to how good it was?
Wow. The question is, did any of these firewalls have ICSA certification, and did that correlate to how good it was? Yeah, I'm going to answer that. No. Some of them did have ICSA certification, and I couldn't honestly tell you how some of them determined that that was ICSA certified. And if there are ICSA folks here in the audience, I'm sorry. I'm just calling it like I see it.
With respect to that, I have a question. Do you really care if it's ICSA certified? What is the certification ICSA certified if it's not money?
The question is, do I care if it's ICSA certified because they just simply write a check and along comes the certification is what he's implying. And I would say no, I don't care if it's ICSA certified. In fact, it means absolutely less to me if it's ICSA certified. When I deploy a security device for a client or for my own use, I want to know how it works and that it does what it's supposed to do. And I could care less about any of the other stuff.
Another misconfiguration question. Like, I do a lot of work with Checkpoint, and there's just like a few things you got to know that you'll leave them by default. They're not even in the rule base, they're like technical properties. If you don't change them, you leave big holes open. Aside from that, it's pretty good. Did you find anything like that?
The question was that the gentleman works with a certain X brand of firewall, and and that there are things that you inherently must know in order to secure the device. Did we find things like that? Yes, we did. We found some ACLs that were just completely unexplained as to how to configure them correctly. And the whole thing is, if you were at Black Hat, you kind of heard my little rant there that I got off on, and I'm not going to do that today, just about how bad support sucked on these products. We would call up and ask, folks that didn't even seem to know what packet filtering was, let alone what to do about it. So I apologize there. Go ahead.
Actually, I like one of the best. I called ProPoint.com. It said, I was looking for the admin password by default. Shoot the gate right out. I think that's perfect.
The gentleman was just letting you folks know that you can find the default admin passwords on ProPoint.com. Thank you. Thanks.
Yes, sir. I got a question, actually. I'm a student, so excuse me if I'm a little ignorant here. You say with your firewall, correct, and I have certain rights between the firewall itself, and I left my computer on when I left work. Now, somebody going to give me couldn't put work and tap into my system without passing the firewall since I already got through.
The question is, if he leaves his device, his computer, as he goes home and he leaves himself logged into the network and his computer's turned on and he's protected by one of these devices, is it possible for someone to access data on your device? The answer to that is yes, determined on how determined these folks out here in the audience are. So those of you who have some of his data, could you give it back? He just realized what happened. Oh, great question. The question was, did we see any OpenBSD-based appliances? There were 2 out of the 23. The OpenBSD. Can't name any names, I'm sorry. They did pretty well, actually. The question was, how did they do in the process? They did do pretty well. What we found was that many of the devices that were Unix-based or Linux-based, amazing, and BSD-based were much more resistant to denial of service attacks than those that were using custom implementations. For some of these folks, they still, if you're writing an appliance firewall and you're still using a proprietary operating system, we like you and you're our friend. Keep coming and make new revisions. We love that.
You mentioned some of them are doing application proxies. What's the level of content inspection And then that brings stuff up to like antivirus servers and stuff like that.
The question is, if they are doing content inspection across a proxy, how deep is that, and are you able to offload virus scanning and things like that? We didn't find any of them that allowed you to offload virus scanning. We found a couple that included some toys that you could kind of place in a DMZ situation that would allow virus scanning of content. As far as the actual checking of the data content within the proxy, that seemed to be fairly robust, although we didn't find any that were configurable in that manner. Anything that was in a configuration issue kind of fell under that content blocking, filtering, I'm keeping you from going to xyzsite.com kind of stuff. So.
Are you going to be listing the names of the firewall in the white paper?
The question is, are we going to list the names of the devices that we tested in the white paper? The answer is yes, for those whose attorneys will sign off and allow us to do so. That's what we're dealing with now. The whole end of this process turned into a big nightmare. It was like some of these vendors freaked out when they found out we were coming to DefCon to tell you guys about it. So.
More questions in the process. You were saying that some of them allow you to create custom proxies. Would that actually just be like creating a patch filter? Did you actually specify the commands that would allow for it?
The question was, how robust was the creation of the proxy process, and could you specify what data signatures or data loads you were looking to prevent? We didn't find any that were configurable to that manner. They simply said you could build these custom TCPs that were kind of like packet filters, and it would make sure that the originating service was indeed, XYZ and this target. So, yeah, it was a little more than graceful packet filtering. Yeah. Any other questions? One for you?
Yeah, some of those Linux-based firewalls, we were told by some of the vendors that it's Linux, but it's a stripped-down version of Linux for security purposes. Are you going to turn that on any of the firewalls, and if so, what tool would indicate that?
The question was, some of these, we've heard that they would possibly use stripped-down versions of Linux as code, and how would we find out? We were not able to determine that. In fact, some of them, our favorite ones, seem to be a full implementation of Linux in this appliance device with a really cool front end, and it did some really awesome things, and you'll see some of that in the white paper. So.
Are any of the network address translation capable firewalls that you dealt with capable of handling H323 packets?
The question is, were any of the appliance firewalls that we dealt with capable of handling H323? And I'm not sure. We didn't test that. I want to mention to you guys as well, while talking about some of these appliance firewalls, that we discovered some things here that you really had to play your cards pretty close to the vest when you were talking to the vendors. We found some that were significantly less than what we would classify as even a firewall. A couple of them were simply NAT devices that did no logging or anything. It just simply NATted your internal and external addresses. And then we found this one, which I'll kind of read about again, that when we asked for the firewall to test, they sent us two. And we couldn't figure that out until we set them up and realized they were just point-to-point encryptors. They were not firewalls. One more here.
Did you ever look into these firewalls capacity or what the intended application was? Was it like T1 slower speed, or was there capacity? What was
the question was, did we test throughput and capacity of the firewalls? Almost all of them came with either 10 megabit ether or 10100 megabit ether. We tested those. We didn't test any of the others. We asked for some token ring implementations, and we got back like, what's a token ring? You have to keep in mind that the majority of these devices are for small and home office users. So, not outside of this room, not many people have T1s hanging out at home. So, that could happen here. Hey, I really want to thank you guys. I'm sorry I can't take any more questions. My time's up. Thanks for coming out to DC7. We'll see you soon.